Recently, someone asked me about my use of voltage regulators in my electronics projects. And voltage regulators, like this one, are the key to power in your robotics projects. So in this video, I'm going to talk about both how you set up this voltage regulator and then also how you do a basic build like this. Let's go over to the bench and check it out. We're just going to be looking at buck converters, and that means that we're going to take a higher voltage and we're going to step it down to the voltage we want. As you can see, there's a variety of different sizes. Mostly it relates to size equals power. So smaller boards can provide less power or wattage, and larger boards can provide more power. There's different ways for you to finish these boards depending on your project. I mostly end up soldering legs onto the boards so that I can use them in breadboard electronics or PCBs. That allows me to make plug-and-play components. In case they burn out, I can easily replace them. You can see here I've shrink-wrapped these ones to make an inline voltage regulator. This means that I can clip this onto the end of a battery or plug this one in line using my barrel jack connector to adjust the voltage. The voltage regulator I use most often in combination with Arduino, especially when working with small motors like hobby servos, are these tiny boards here. They're really terrific. They come in a block and you sort of just snap them apart on the score lines. When you solder the legs of this tiny board, be aware that the pitch on this board does not match the pitch. If I line up these little boards with my breadboard, I can see that along this edge, the holes line up nicely. But then on this edge, they do not. You can see they're slightly out of phase. And so just allow them to bend inward a little bit so that they find their correct spot in the breadboard. And I find they mount just fine. Before you use your voltage regulator in your project, you'll want to tune it and set the voltage. I keep a 12-volt barrel jack connector next to my desk for tests like this. So you can see that out of the box, this voltage regulator is almost giving us the full 12 volts from the input. But now I'm going to use a screwdriver, and I'm going to turn this tiny screw here, and we're going to watch that voltage drop. If I was going to connect up a hobby servo, I would dial this in to right around 6 volts. That should be plenty to power something like a hobby servo and give me good behavior. And now that the voltage is adjusted, it's time to install my voltage regulator on my project board. I've got my Arduino Nano here, and then the voltage regulator tucked in nice and close behind it. The power is going to come in on this little 2-pin connector. The ground is going to be passed directly to the ground rail, and that's shared by the Arduino and then also by the voltage regulator. The 12-volt input voltage is going to go directly to the Arduino V-in pin, and that's okay because the Arduino has its own voltage regulator and it's going to step that down for what it needs. And of course, the Arduino puts out its regulated 5-volt signal, which you can then attach to the positive rail for connecting things like sensors, such as a knob. But here you see that 12-volt power is also passed over to the voltage regulator. It is going to step that voltage down to 6 volts and pass it up to this top power rail, which we are then going to use to power something like a motor, for instance, a hobby servo. Notice that both the voltage regulator and the servo are connected to the ground rail, and that ground rail is redundantly, again, connected to the Arduino board. This means that all the voltages will share the same ground, and this is really important. If you don't do this, you will see some very interesting behavior. Well, that wraps up my basic introduction to using a voltage regulator in your Arduino project. I hope you enjoyed that. Please mash those buttons, give me comments if you got them, and I'll see you next time.